welcome to the very first episode of Let's Explore. My name's Neil Studd, and this is a series where I'm going to be showing some of the stuff that we do as testers on a daily basis that perhaps you don't see. A lot of time that we spend investigating things, experimenting with things, getting things wrong, bodging things, that sort of thing. So we did a trial episode on Twitch last week, which went quite well, apart from connection issues. So this one I'm going to pre-record just so that everything's intact. We'll see how this goes. The idea behind Let's Explore, we're going to have a small mission or objective that we're going to do in each session. So it's going to be something like, I want to investigate this website, or I want to try and complete some activity. But I'm going to go into it blind. I'm going to do as little time as possible investigating beforehand. I want this to be completely fresh, so you see the various ways in which I stumble as I go along. The reason why I've recorded this episode so quickly is because I had the idea for the episode and I haven't been able to stop thinking about the problem. So the more I think about it, I'm like, no, this is supposed to be completely fresh. So what you're going to see is completely unedited, not just because I can't speak properly, but because I want you to see how much time I spend Googling for things, the fact that it's not a sin to look on Stack Overflow and see how someone's attempted a problem before. There's no point in you trying to burn hours and hours trying to solve a problem that someone else has already dealt with. And particularly, we're going to talk about a programming language today. No one expects you to hold that entire programming language in your head. As long as you know the names for the concepts of what you're trying to do, you can still get the job done quite quickly. And we'll make mistakes along the way. That's all part of the fun. And I'll upload the resources that I do afterwards. So, for example, we're going to be writing a script today. I'll let you access the code to my script. You probably might have more fun doing it yourself, but it'll be there for anyone who wants to look at it. So without further ado, what is it that I'm going to be doing today? Well, this one is an episode called the Python Lottery. What I'm going to do is we're going to write a Python script which runs a series of fake lottery draws. So I'm going to generate 6 random numbers, and I'm going to get the script to compare it against 6 numbers that I've chosen, and we're going to run it again and again and again and again, and we're going to see if we can win the jackpot, or at least get as close as possible. Let's see if we can get 5 numbers maybe. We might be able to do that on camera. 6 might be a push. We're going to do it in Python, which is a language that I use for any little bits of scripting that I want to do. People always say, which languages should you learn? If you want to do just random little bits of scripting, Python is good, Ruby is good, JavaScript is quite powerful as well, depending on what tool you're using to run it, for example. But Python always gets the job done for me, and it's a language that is relatively straightforward. It's a relative newcomer compared to some of the others, so it's quite... they've learned a lot of lessons from mistakes that people have made in the past. We'll see as we go how that happens. Right, let us exit the slideshow without stopping the movie. We're still recording. Yes, excellent. So we just bring up Python. I'm just going to use Python's built-in editor, which is a tool called Idle. There are better ones out there, but much like I go back to Notepad when I want to write some notes, I just like the purity of having a clean face here. So there's quite a few parts to this. The first thing I want to do is probably the hardest bit, which is just selecting 6 random numbers. Now, I'm going to double check the names of the things that I'm going to be doing, but I think I just need to import a library called random. But let's just do Python random number. Now, it's going to be very hard to avoid accidentally finding the answers to my own problem here. I don't want to find someone who's built a lottery tool. I just want to know what's the call I use. Now, W3 Schools gets a lot of crap for being a bit... some of the stuff on here is a bit out of date, or it's a bit, it's not the best advice, but this might do me. Ooh, shuffle. I was looking for one number. Is there a thing called shuffle? Takes a sequence. Oh no, it takes a sequence and reorders it. Returns around. Okay. I was just going to start picking random numbers and then do that 6 times. It's probably worth a quick look through here. Is there stuff in the random library that will do this for me? So a random number in the given range, yeah. Returns a random element from the given sequence. Returns a given sample of a sequence. No, I'm going to stick with what I know, which is I'm going to get a random integer. And if you do round int x to y, it will include both of those in there, which means that what we want to select one random number, we'll just select one random number first of all. Just do print random dot. I don't need to do random dot, I don't think. I think we've imported the library, it already knows that. Randint, give me a random number between 1 and 6. And if we, need to save the script. I'll save that as let's explore episode 1.py. Invalid syntax, brilliant start. Okay, yeah. So This is one of the things that changed between version 2 and 3 of Python. You have to start putting your prints in brackets. I should have remembered that. If I run this, do I get a random number? No, that went well. Randint is not defined. Maybe I do have to do random.randint. There we go. There is a 4. Now, I'm going to do the numbers 1 to 49. I know they changed the UK lottery a few years back to, I think it's 1 to 59 now, but I'm old school. So I'm going to do, that will give me one random number between 1 and 49. Now, the issue is, you can't just do this 6 times because it could pick the same number twice. So I'm going to stick this inside a function. And what we're going to do is we're going to use, we're going to do some refactoring on this over time. I'm going to do quite a lazy / brute force approach first of all, and then we're going to see how efficient that is, how long it takes to run, and then we might try and refactor it and make it better. So I'm just going to call this get draw numbers. It's not going to take any inputs because we just want 6 numbers back. For I in range equals I in range 6. This is going to iterate over this 6 times. So let's prove that we're doing it wrong. If I say, let's imagine the numbers were only between 1 and 6. If I run this now, it will print 6 numbers. No, I didn't actually call the function. So I defined the function, but then beneath this in the script, I'm going to put, just so you know what's going on, script starts here. Now let's do get draw numbers. So if I run this, we'll get 6 numbers, but they will be, I picked number 1 3 times, which isn't quite what we want. So what I'm going to do, so I'm going to do the lazy approach first. I'm going to define a list of numbers. I'm going to say draw numbers equals y. This is what I've done there is I've created an empty array, and then each time I go through this, I'm going to say now I think it's dot push to add an item to the array. So let's use this with the old code, and then at the end of our function, if we do return draw numbers, and then we print that out. So what I'm saying is, I haven't actually changed the functionality yet. I've just said I'm going to start with an empty array, draw 6 random numbers and stuff them into this array, and then send the array back, and then the script will print that array. So this should do the same as last time, unless I've got things wrong. List has no object push. Let's Google it. I do a lot of my day-to-day work in JavaScript. I suspect I'm getting things confused. It's append is the keyword we want. Looks like I've Googled for it before. So if we append that to the list and we rerun it, we'll see 6 numbers. They will include duplicates. Oh, 651342. I think I fluked that. Let's run it again. There we go. There's some duplicates. That's really spooky. The first time I got 6 unique numbers. The odds. I'd be interested in the odds of doing that. 6 numbers with no repetition. But what we'll do this time is I think just a way that will work. I'm going to create a variable called is there a while keyword? There is. Right, while. Right, I'm going to create a thing. Again, this is very long form. X equals null. No, I think none is the word you use in Python. Well, x equals none, and let me Google this again in a second, and x what am I trying to say here? X in draw numbers. What I'm trying to do here is X equals, let me get this out of my head and then I'll explain what I think I'm doing. So this time, whenever I try and pick a new random number in this while loop, I'm going to say have we picked a number yet? So while x is none, so the very first time we come into this loop, x is going to be none. And no, or this wants to be an or, which I think is pipes. You know, I'm going to Google this because I don't want to get it wrong. Python or expression. Can you just write the word or? Can you just write the word or? So every time we come into here, what I want to do is I'm going to pick a number and check whether it's already in the list. And I hope that's what this is doing. The easiest way to try it is by running it. Invalid syntax, that's a good start. X equals, it's a double equals, I think. Okay, so that time it's run. It does appear to have chosen unique numbers every time. What I'm going to do to test this is I'm going to just stick a statement here called print picking. Now, on any given, in fact, let's make it even clearer. Picked X. So this will tell us how many times it's actually gone through this loop, I hope. And Python is fussy about types, so X is a number. If I want to add that to a string, I have to tell it actually give us the string version of X. That's one of my pet peeves at Python. If you want to print a number in a string, it's really easy to convert a number to string, and I wish it would just do it. So there we go. There we go. This proves it's doing exactly what we want. So at the end, we've come out with 6 unique numbers. But along the way, it's gone 1, 5, 6, 3, 6. So it's gone 6. It's thrown that one away. Then it's gone 5. Then it's gone 4. It's gone 6 and 6 again. So in other words, there are duplicates in this. But at the end of the day, it brings back 6 numbers, which means we can now safely change the script to 1 to 49 and know that it's going to bring us back 6 random numbers between 1 and 49. I'll take the print statement out because it's going to be noisy, and just prove we've got something that picks at random 6 numbers. Now it's harder to prove that they're not duplicated, but that's why we did that check before, to make sure it really is deduplicating the list. We're going to come back to that function later to try and make it better and more efficient, because that felt ugly. The fact that it was difficult to explain to you, the viewer, what I was doing proves that that is not great code. It certainly isn't ship it to production code, but it's good enough for what we're doing right now code. What I'm going to do, one of the things I like to do when I'm doing this sort of thing, is I keep myself a little to-do list. I'm going to do it at the top of the script. Refactor, get draw numbers. One thing I'll also do is add timers to it. So what I want to know is how long it takes to do that. Because then when I write something that's better, I can see whether it's also quicker, because the thing we care about is how long this is taking. So I'll come back to that. Let's do the script itself now. So what we want to do is I'm going to give the script 6 numbers, the numbers that I've picked. I'm going to hard code them in the script for now. Maybe in the future we'll actually make it so these are passed as inputs, and you can actually ask the user what numbers do you want. I'm going to I'm going to use the numbers from Lost for a 15, 16, 23, 42, if I remember correctly, was the magic numbers in Lost. Those are my lottery numbers. I also know, I think a lot of people use those in real life. It's the same as using 1, 2, 3, 4, 5, 6 in real life. You know, it's fun, but if they ever come up, you're not going to win anything because everyone else has done it. I think there was an American lottery draw where at least 5 of those numbers came out and no one won anything because everyone had used them. So what we've got now is we've got my numbers. And what I'm going to do is I'm going to create a variable called today's number, or lottery number, or actual numbers. Let's give it something that's vaguely picked numbers. I want to give this a name I'm going to remember. Lottery draw. I'm going to call it lottery draw. Equals get draw numbers. So rather than printing it out, we're going to save our numbers that we picked into there. So what we've got now is the numbers I want to use, an array that's come back with those numbers in it. So now what I want to do is check how many numbers we picked. And again, I'm going to do something that's going to work, but not be the best way of doing it, first of all, and then we'll come back and refactor if we want to do that. Def check my numbers, or check, put check ticket, check, check numbers. I'm going to pass in, I'm going to call it my numbers and lottery numbers, lottery. Picking names for things is really difficult. So my ticket and actual numbers. I'm going to refactor these names of things because these are not good names. So what I'm going to do is for number in my ticket. So I'm going to loop around every number on my ticket. And let's start with set a variable called numbers matched. Numbers matched equals 0. So to begin with, we come to this function, we've got no numbers. We're then going to go through my ticket and look at every single number in turn and say, again, I'm going to write this long form. A lot of this will collapse down in a minute, but if number in actual numbers, this is why I like Python. A lot of this is really intuitive. So if the number I've got is in the actual numbers, numbers matched, add 1 to it. And then at the end of that check, we can just do return numbers matched. And that should give us how many numbers we've got. And we can prove that with some debug statements. So at the end, I'm going to say print my numbers. Now again, I don't know what happens if you're trying to append an array to a string, whether it converts it properly. We'll find out. And print actual numbers. And print lottery draw. And then I got, and then we do have to do a string conversion on this, we know. I haven't done check numbers yet. Result equals check numbers, and pass in those two lists of numbers. So result will now hold the number of numbers that I've matched, if I've got this all right. So let's have a look. No, not check numbers, result. I got that many numbers. Odds of this working first time, pretty slim. There's a very high chance I made a syntax error somewhere, but let's have a look at whether that's done its thing. My numbers, okay, we can't concatenate that to a string. Our friend Google, Python, concatenate array to string, or Python array to string will do. String brackets anything will convert Python object into string. Who knew? So I've been using, oh, accidentally open a tool, didn't mean to. Turns out you can just stringify anything and it will make a nice string of it. How nice remains to be seen. Let's have a look. Have we at least got through this without any syntax errors now? Ooh, I got two numbers. I did. There we go, 16 and 42. Basically, that code that I wrote has worked. I'm going to add to the list to do refactor check numbers. It's probably not much to do in that. You're just going through two lists. I feel like there's probably almost literally a one-liner you can write that would do that. I like the fact that that is easy to understand what it's doing. So for the purposes of today, I might leave it alone. What I want to do now, though, is the benefit of now having this all in script is, of course, we've run the script for one draw. We should just as easily be able to run this for 100 or 1,000 or 10,000 draws because we've got the functions to do it. So that's what I'm going to do. What I'm going to do is let's start a new loop here for draw in range 100. I'm going to do 100 draws. Let's do 10 for a second, just to begin with, just to prove that we've got a loop working, and then we can just increase that number. This week's draw equals get draw numbers. This week's result equals check numbers. Remember that I've renamed that. So I'm using the same numbers every week just for simplicity's sake. And let's print week and draw string. This is going to start at it's 0 base, so I'm going to put again, for simplicity's sake, draw number equals draw plus 1. There are neater ways of doing it, but week X, oh, Mr. Plus, numbers, then I'm going to print the numbers, which is string this week's draw, and then I'm going to list how many numbers I matched. So that's string this week's result matched. Now that was a pretty long line, and again I'm looking at that and going, is this going to work? What I'm expecting to happen is it's going to loop around this 10 times. Oh, too many equals is in there. It's a bad copy and paste. It's going to go around that 10 times, generate 10 different lots of numbers, and check 10 times how many numbers we've got. Let's have a look. Ooh, right, let's pull this out so we can see. That is 10 weeks. 10 weeks in which the most I did was match one number by the looks of it. So there's an 8 there, which is in our numbers. And there's a 4 there. So yeah, turns out I suck at picking lottery numbers, and or the lottery is bad at helping you make money. What I'm going to do now, the next iteration is I'm going to massively increase the number of times we run this. I'm going to put it up to 1,000. What I'm going to do is comment out this print line so it's still there if we want it for debug purposes. I'm only going to print out if we've actually won, basically. So if I'm going to rename this week's result because that's annoying me already. Rename it to numbers matched, which is the same thing that was called in there. And rename it back in this comment just in case. If numbers matched is greater than or equal to 3, basically print out that same statement. So it's now only going to print out the times we've matched 3 or more balls. For 1,000 draws. You know what, let's be nice. Let's give it 100 attempts first of all, just to make sure it's working. Now, either I didn't win in 100 draws or my code's not right. Which do you think? I'm going to run it one more time. Yeah, let's just do that one more time. Turns out first 100 draws I didn't match. Here are 3 draws that I did match on. 8, 16, 23, yeah. 4, 16, 42, and 4, 8, 23. Yeah, so I bought 100 lottery tickets, which in the old days was £1 a ticket. And in the old days, 3 numbers used to get you £10. So 100 lottery draws, I won £10 3 times. That's rubbish. Let's see. That ran quite quickly. I'm going to bump this up to 10,000. Let's go crazy. I've not written any optimizations for this, so anything could happen. Sitting, watching random numbers go through. Can you do a find in the console window? Let's have a look. Because what I want to do is find occasions. Okay, so there's a 4 match there. Did we get any 5 matches in there? No, the best we did was 4 matches. How many times did we get 4 numbers? 1, 2. We've got 4 numbers a few times. So hit the one I paused on here. We've got 4, 16, 23, 42. We actually got the first 4 numbers out. If we were watching that draw, we'd have been getting excited thinking we were going to win the lottery. But there we go. 10,000 goes. I didn't match more than 4. What I'm going to do at this point is, what I want to do is massively increase this number to try and let us get 6 numbers back. But now that we're doing 10,000 draws, let's take a quick pause and see if we can make this run more efficiently. I'm going to stick some timers in here. I think there is a Python library called timer that lets you do timer start and timer stop. But it's been a while since I used it, so let's just do Python timer library. I'll favour this actual site over. I really like sites that actually have curated their own content and someone's actually sat down and thought about this. I'm going to do search for timer.start. No, okay, it's a bit more complicated than that. Just want something easy. If I start at the top, do I get an easy example of a timer? I do. T. Okay. I don't care about loggers. We're not starting near enough to the top. Come on. My fault for not starting at the top. Lots of things. Okay, so import time. Time.perf counter takes the thing. And that tells you how many seconds have elapsed. Okay. I'm going to take this. It's not. There are better things in Python. That's the point of this article. But I'm going to do the thing that gets me what I need the quickest right now, which is going to be import the time library. And at the top of the script, I'm going to do start time equals time.perf counter, perf underscore counter, which stores a number of seconds. At the end, after we've done all this looping, I'm going to do end time equals time.perf counter, which calls another one. And then print completed in, I'm going to stick this into another variable just for the understanding's sake. So elapsed time equals end time minus start time, and we completed in string elapsed time seconds. Let's run our 10,000 draws again and see how long it actually takes. It's not the slowest. And I know actually printing these messages out is one of the things that actually slows down a script. If we actually switch these off, which I might do in a second, we'll prove how much faster it goes. So that completed in just under 10 seconds. If I comment out the print statement, because that is consuming CPU time, if I run this again, just a quick tip for if you're trying to expected an indented block. Okay. I'm just going to set y equals 0. Basically, you can't have an if and then have nothing going on in it. So I'm just going to set a variable to 0 for the hell of it, so that's doing something. There we go. It took a tenth of a second when I wasn't doing all that printing out. So it's nice to print things out, but actually the biggest time saving is don't print those statements out. That's interesting to know. So rather than doing any refactoring right now, what I'm going to do is I'm going to change this to only tell me if we get 5 or more numbers, because I think we'll still get through this quite quickly. Because if I do that, give me 100,000 and tell me when I get more than 5. So print, we will really do a print, but only if we get greater than or equal to 5 in 100,000 draws. So spending £100,000 on tickets, how quickly can we do it and how much do we win? Well, on 2 occasions, we got 5 numbers. I think 5 numbers, again, in the old days was, we haven't thrown the bonus ball into the mix, but I think just 5 numbers is only a few thousand. So definitely haven't made our money back there. However, it only took 1.1 seconds to do, which has made me feel very optimistic about our objective here, which was let's win the lottery. Let's buy 10 million, checks his numbers of zeros, 10 million lottery tickets. What do you reckon? I think the odds with 6 numbers back in the old days of the lottery was something like 1 in 14 million, so this may not be enough. Heck, let's try and beat the odds. Let's do 20 million draws. I hope it's not going to crash the computer. Let's run this, see how long it takes. Oh, I forgot to change it from 5, so we're going to win 5 a few times. Here we go, some 5s. Keeps the excitement up. Still not that many wins, you know. 5, 5, 5, 5, 5. Are we going to win the lottery? We're going for 28 minutes. If we can win the lottery in under half an hour, that's quite an achievement. Still only on 5s. We're so close. It's almost like it's really hard to win the lottery. 5, 5, 5, 5, 5, 5, 5, 5. Again, 20 million tickets, we should theoretically have beaten the odds. Although each one only has a 1 in 14 million chance. It's not like the odds get better the further we go. Again, it's the floor of the lottery. And this time there are pauses between messages, so it really is hammering through these random cycles. Folks, I'm disappointed that we've not won. We're up to 5 million draws. We're £5 million in debt now, having tried to win the lottery. Week after week. How many weeks is this? Alexa, how many weeks in 6 million years? Oh no, not 6 million years. Alexa, stop. Sorry for everyone whose Alexas I've just set off. Alexa, how many years in 6 million weeks? She's not listening. Alexa, how many years in 6 million weeks?
6 million weeks is 115,100 years.
115,000 years. Just check I haven't missed any sixes along the way there. I didn't know. Okay. This is somewhat disappointing. What I'm going to do is when we finish this 20 million, if we don't win, I'm going to change that code to say if numbers match is 6, so we only see the 6s, so that I don't have to sit here watching all these 5s. And then we'll let it run another 20 million just to see if we win 6. And then maybe we'll look at this while that's running. I will run this. We'll talk through what else I might do to this script. 12 million tickets, not a single winner. I am. I won't say I'm surprised, but I hope we might get a win. 13 million. Come on, we're up to 15 million tickets. What I want to do is abort the script, but just like buying the lottery itself, I'm worried that, if I stop this now, maybe that's the one that was going to win. I've been staring at this code so much that number 5 no longer looks like a number. I'm like, is that a 5? Is that what numerals look like? It looks like a... yeah. 17 million and no wins. I'm now worried that when I was talking to ALEXA, I missed 116. Okay, we're almost done. No winners today. How much time do we think has passed? Feels like a long time. Is it 2 minutes, do we reckon? It was 200 seconds, that's 3 minutes. Okay, right, let's change the script to only tell me if we get 6 numbers. And do it 30 million times. Off you pop. There we go. Now, while it's doing that, while it's sitting there not winning the lottery for me, that's kind of the first objective is complete. We could certainly talk about the fact that we could do refactors on it. That's why I wrote to-dos. They're reminders to myself that I could go back and do some more stuff there. But this code, for the sake of what I'm trying to do right now, has served its purpose. So maybe there's not much value in rewriting. We saw the biggest time saving was from taking out those print statements because it just makes the whole thing run faster. It's not going to worry about outputting stuff to the screen. So possibly good enough for today. What I might like to do in the future, when I first intended to do this episode on Twitch, what I was going to do was I was going to say to all the viewers, let the viewers pick numbers. So actually we send lots of numbers through this, and each week we check John's numbers and Sarah's numbers, and we see if any one of the viewers can win. Now we haven't got anyone else live on the stream here because it's pre-recorded, but it might be an interesting thing to do in the future, see if we can get a win for anybody, because my script is still running away in the background and it is not winning. I'm going to let this one finish. We know it's going to take maybe 4 minutes to run, so I'm going to ramble on to the end of this video and see whether we actually do get a win. But I mean, we've matched 5 numbers a lot of times. We can see up there 4, 8, 23, 15, 16. Just the 31 there was the one that didn't work out for us. But that's a little example of, hey, that would be a fun exercise to do. I bet we could do that in Python. And it wasn't too hard. One of the good things about Python is any time that I got it wrong, the messages that kicked out were fairly obvious. Once you've seen each error message a few times, you've seen them all, and you're like, oh, okay, that's the thing that I forgot to do there. It's also something that you can Google very easily and find either pre-existing libraries. So that thing where I was working out the timer, the time library does it. It looks like that article had a whole load of other things that you could use for better, more accurate, like performance scale testing or writing out log messages. But what we've done is a script that does the thing we wanted to do, and it got it done. And we've still not won the jackpot. So I will wrap this episode up now. I'll let the script finish, but this is basically the end of episode 1 of Let's Explore. We've shown that we've met our objective. We've drawn 6 numbers and matched how many we've got. We've run it 20 million times. By the time the script finishes running, we'll have run it 50 million times, and we may still not have won the lottery. About the only thing I think I forgot to do was when I started the recording, I forgot to put my nice Yeti microphone onto there. I don't think I'm recording through this. I think I'm recording through the sound card on the Mac, so it's probably been a little bit tinny. Sorry about that, but this is just a quick example of making things up as you go along. It can be fun, it can be educational, and unfortunately it can't win you the lottery. The script is not quite finished yet. I feel like it's got maybe 1 more minute maximum, and then it's going to come back and tell us how unsuccessful we've been. But just got to vamp for time now. It's fun for everybody involved. It's almost like I should have used the print statements to show how far along it was. But that also would have, if I had print statements on, if you remember, when we were doing 100, was it 10 or 100 draws we had, and it took 9 seconds. If you move that up to 30 million, and if we're printing out every single one, I suspect we'll still be here tomorrow printing those out. So taking the messages out has helped us. We just have to have faith that it's doing its thing in the background, and it's not stealing all my magic lottery winnings. Come on, script. What I will do after I upload this video, I'm going to run this hundreds and hundreds and hundreds of millions of times, and I'm going to upload a screenshot of when I eventually win to tell you how many times through it took before I actually won. Because I'm determined that I will win. I mean, we can beat the odds, that's what they're there for, but if anything, this made me feel very happy about not buying lottery tickets, not least because, yeah, they changed the UK lottery a few years back. They changed it. I think the numbers are now 1 to 59, and they doubled the price of the ticket, so they massively decreased your chance of winning and made it more expensive. I think there's a new level where you get a free ticket if you match. I don't know how many numbers you have to match to get a free ticket, but yeah. Some people can beat statistics, but not everybody can beat the statistics. That's how they make money. We should be able to figure out how much longer this is going to take to run. If it took 200 seconds to do... Oh, there we go. It's completed. 278 seconds. That felt like more than that. Maybe it's because I'm not used to talking nonsense for a long amount of time. But another 30 million tickets down the drain. We did not win, but hopefully we had fun doing so. I'll upload this script. So if you go to... in fact, there's a link on my Twitch profile to the Let's Explore resources page, but I'll tweet it out as well, and I'll put it in the description of this video. The place where you can go to get my script that I've used here. Would love to see people writing better examples of these functions. Both of these I think can probably be done as almost one-liners. This bit here in particular is really brute forcey. I'm going to go away as well and have another go at that in my free time to just make better code. But hope you've enjoyed the video, and look forward to seeing you all again soon. Bye.